In part 2 this question, question 2b part 2, we have to then factorise the polynomial. Well, we know that x minus 4 is now a factor. If we take out a factor of x minus 4, we're obviously going to be left with a quadratic. So we know that x minus 4 multiplied by some quadratic, x squared plus bx plus c, is the same as our polynomial. So if we compare coefficients, I'm going to look at my x cubes first. The only way we can create an x cubed function on the left hand side is by multiplying ax squared by x. So we have ax cubed on the left hand side, which must be the same as 2 on the right hand side, because that's our only x cubed coefficients. Looking at x squared, the only ways we can create x squareds on our left hand side is by multiplying x by bx, which is bx squared, and minus 4 times ax squared, which is minus 4ax squared. And on the right hand side, the only x squared coefficients are minus 3. We know what a is 2, so b minus 4 2's, which is 8, is equal to minus 3. b is equal to minus 3 plus 8, add 8 to both sides, that gives us 5. Then I always like to look at just the constants. The only constant that's generated on the left hand side is minus 4 times c, so minus 4c, and the only constant on the right hand side is 12, so minus 4c is equal to 12, c therefore is equal to minus 3. So if we sub in our a, b and c values, our expression looks like this, 2x squared plus 5x minus 3, and it says factorise, so we need to get this quadratic hopefully into two brackets. So we have x minus 4, we're obviously going to have a 2x and an x. The only two numbers that multiply to make 3 are 1 and 3, and I'm going to put my 3 here and my 1 there, and we can see that we'll need a positive 3 for the 6x and a negative 1 for minus 1x to make the 5. It doesn't say solve, so we leave the question in this form.